And now for something completely different. You guys can all relax, we don't really have any math. Instead, we're going to be looking at Wittgenstein and his philosophy of language and how it influenced modern NLP. Why Wittgenstein? We're studying AI, not philosophy. But AI is inherently multidisciplinary in that we pull from many different fields in order to build out an understanding of how the world works and how we can model intelligence. Neural nets, for example, pull from neuroscience, and philosophy of language is a way of thinking about language. These ideas can help us better model natural language. Tying this back to Wittgenstein, his ideas, especially surrounding context and the meaning of a word, have both indirect and direct influence on modern approaches to NLP. So who was he? The philosophy of Wittgenstein is typically divided into two different periods, early Wittgenstein and late Wittgenstein. Both are characterized by very different views on language. Early Wittgenstein is centered around the Tractus Logico-Philosophicus, often called just the Tractus, because that's a name. The view presented in this is based on the idea that language, logic, and truth in general can be proven to be true, and only that which can be verified or proven directly has meaning and is worth talking about. For example, in this way, metaphysics is not just wrong, but it's entirely meaningless. And after publishing the Tractus in 1929 and receiving his PhD from Cambridge, he left philosophy thinking that he had solved the field. A few years later, he returned with concerns regarding the logical formulations he presented in the Tractus, namely that they focused too heavily on syntax, not of language as a whole. And this marks the start of late Wittgenstein, where he began to completely reject the idea that understanding is inherent or absolute. Instead, context is key. To this end, he began to assert that language is not prescriptive, but rather descriptive. It only matters or makes sense in the way it is used. The idea of a word having meaning in the way it is used gives rise to the idea of a shared context between people. This he coined as a language game. And when speaking to others, we play this game in order to convey the ideas amongst ourselves.
The later Wittgenstein said that context matters when trying to understand the meaning of a word. This should ring a bell. We saw this idea in the NLP lecture when discussing linguist John Firth's most famous quote, "You shall know a word by the company it keeps." If we look at the context around this quote about context, boom! There's Wittgenstein and his philosophy. That's not an accident. Wittgenstein thought of this originally and published first, but gets way less credit than John Firth. Philosophers like Dan Dennett here have asserted that the later Wittgenstein tried really hard to be right, but ended up being probably wrong and most definitely confusing. Language games is central to Wittgenstein's philosophy and is one of those concepts that earned him this mixed reputation. I'm going to try to define it, even though I'm pretty sure this is what killed him. So here's a list of examples he gave for language games to support his intuition: giving and obeying orders, describing properties of objects, drawing, given a description, etc., etc. He thought that all language games could be seen as one big family that covers everything we do involving language. But you'll notice pretty quickly that you can't come up with a satisfying, concise, and logical definition that penetrates all of these examples. The closest that Wittgenstein got was that you'll know which game you're in via context. Each game has its own socially governed rules, and these rules can change over time. But Wittgenstein said, that's no problem. We don't need to think and come up with a clear-cut definition. Instead, we should be happy with a fuzzy one. He did what philosophers have done since the ancient Greeks and used analogies in place of a concise definition. So all these language games don't share a set of common attributes, but they definitely have overlap. And Wittgenstein thought that that was enough for traction in language philosophy.
So we can examine some of Wittgenstein's other quotes to better understand what he meant by context. So Wittgenstein says that a language game is really a form of life. It's intrinsically tied to a context, whether that's cultural or situational. Here's an example of that from the comic strip Calvin and Hobbes. Calvin, what are you doing? Now, what are you doing can apply to a lot of contexts, but the specific use of what are you doing here as a rhetorical question is unique to this particular context, and it's hard to understand once you've separated it from that context. So language is pretty complicated. In addition to that, Wittgenstein described language as an ancient city. It's full of little streets and squares, old and new houses. So in addition to being complicated, language is dynamic and growing. One way you can think of this is in the slang that gets added to the English language every year. What happens when we don't consider context? We can examine a famous example from machine translation in the 70s. So the input is a line from the Bible. The spirit is willing, but the flesh is weak. The output was in Russian, but what the Russian read was, the vodka is agreeable, but the meat is spoiled. So both the meaning and the context have been distorted. So what we can get from this is, language isn't just syntax and grammar. There's a whole lot of abstraction of language in the form of idioms and metaphors that basic rules cannot capture. So in the field of NLP, what do we have to learn from Wittgenstein? Wittgenstein said, use is meaning, so as NLP researchers, we want to learn from context. Wittgenstein said the language is irreducibly complex. As computer scientists, we want to use as much data to try to capture that complexity as closely as possible. And that's already being done. For example, GPT-3 has 175 billion parameters and is trained on a huge corpus. Just as a refresher from class about 2 weeks ago, Word2Vec is a context-driven model. It looks at individual words and deciphers their meaning based on the words around it in the corpus. First, it vectorizes the words, it creates embeddings, and then once these embeddings are graphically depicted, the closeness between the clusters of words indicates their closeness in meaning.
So far, we've seen the evolution of language models from machine translation to Word2Vec. However, there's a critical shortcoming of Word2Vec. Word2Vec condenses all context into a single vector, which performs poorly on polysemy. A polysemy is a word that can have different meanings depending on the context. For example, play here is a verb. The same word is a noun. They are not the same in different contexts. The probability of each occurrence depends on the surrounding word, which Word2Vec fails to consider. So computer scientists team up with linguists to overcome this limitation. So unlike Word2Vec, context-to-vec is more descriptive and agile. The first diagram shows the architecture of bidirectional LSTM with context-to-vec. The blue and green boxes show the model learns from the forward and backward feed to examine the surrounding context-to-vec embeddings. The details of the embeddings are specified in the second diagram. The triangle indicates context, and the circle means words. The context-to-vec maps not only the relationship between context to context, but also context to word to enrich the understanding of the text. The empirical results show that context-to-vec with more training iteration outperform its benchmark in the sentence completion task. So language models are getting more and more sophisticated with the new embedding techniques to the point that they're able to get the use of word to some capacity and complete a sentence. To accomplish this, language models should learn not only the rule-based syntax and semantics, but also the social norms and general understanding of the world. In other words, we need to teach machines some sort of common sense that is implicit in the training corpus. This current situation poses several challenges. First, the embeddings are very rigid. They always use the whole sentence for learning the context, which might fail to generalize over the whole paragraph or passage. So we should be able to teach machine about the context that is spread across variable length text. Also, the performance is closely tied to computational resources and corpus. To fix this, we need to be able to augment the ability to infer by embedding some domain-specific knowledge. So inspired by Wittgenstein's language game idea, we call this approach game-to-vec. So finally, just to recap the presentation, we can summarize the key takeaway as follows. First, word embeddings are mostly attributed to John Firth, but Wittgenstein is the person who came up with the original idea. So he deserves more credit for the development of word embedding techniques. Also, language is such a complex system of rules and social norms, so rule-based approach often fail. Which means by solving the key to language, we can potentially unlock artificial intelligence because language is a useful measure of intelligence. To that end, bringing together fresh perspective can be really valuable. Thank you for listening.